Hey guys, welcome to my channel. In the previous lecture, we have seen how to update the vertex and edge records of final subdivision. In this video, we are going to see how to create a face record for final subdivision. So if you can remember, in the face records, we have three attributes. Those are inner component, outer components, and the incident face pointers. First of all, how many face records will be there? How many faces will be there? Well, except for the unbounded face, this is the unbounded face, we have a unique boundary for every face. So the number of faces equals to number of outer boundaries plus 1. So how do we recognize this outer boundary? It's fairly simple. Look at the example here. The angle bit, we have to consider the leftmost point of every boundary. So for this boundary, consider the inner one. This is the leftmost point. So the angle at this boundary, if it is less than 180, it is the outer boundary. Indeed, it's the outer boundary of face F. And consider this boundary here. It's a leftmost point, and the angle at this point is greater than 180. So it's a boundary of a hole. Yes, it's a boundary of a hole of face F. So in this way, we will recognize the boundaries, outer boundaries, and the boundaries of hole. So now that we know a number of faces on the outer boundaries, to know which boundary bounds which face, we have to construct a graph. The inner and outer boundary combinedly become one node in G, and so every inner and outer boundary, suppose this inner and outer boundary combinedly become one node, and we also give an imaginary boundary for unbounded face and give it other node. So the number of nodes equal to number of faces. It's very simple. Now I'm going to tell two statements which should be clearly understood. There is a link between two cycles, that is two nodes here. If and only if one of the cycle is the boundary of a hole, the other cycle is a half edge. The other cycle has a half edge immediately to the left of the leftmost vertex of the whole cycle. I will repeat the statement once again. There is a link between two cycles or nodes here if and only if one of the cycle is the boundary of a hole and the other cycle has a half edge immediately to the left of the leftmost vertex of the whole cycle. Suppose consider this C3 and C6. The leftmost point of C6 is this, and that has a edge. Now this whole boundary has a edge to the leftmost point of C6. So we can there is an arc between C3 and C6 which is shown here. In a similar way, at the leftmost point of C3, we have a boundary. We have the edge of C2. So in that way, C2 and C3 are linked here. The leftmost point of C1 has an edge, doesn't have an edge, but we imagine it has an edge. We imagine an imaginary boundary for an infinity, so we cannot see infinity and C1. And for C4, for example, doesn't have an edge because it's an inner one, so it will be left at that in the same way. C5 and C6 is left the same way out. So this is the graph we have constructed. So what are we going to do? Well, once we have the graph G, so we call this graph as G, we can create a face record for every component. Then we can set the incident face pointers, and we can construct the list inner components and set outer components of F. So how to construct this G? It's very simple. Recall that in the plane sweep algorithm for line segment intersection, we always looked for segments immediately left to the event point. So when we reach this event point, we know that this has a segment to this left. If there is a segment, we will connect an arc between these two boundaries. So in this way, we construct the G at in the process of sweeping only. So in this way, we will set the records of our face list in our doubly connected edge list. There is one thing left, which is labeling the faces. So how do we label this? If V is an intersection of edge E1 and E2 of S1 and S2 phase subdivisions, uh, we have to label this F, which can be done by looking at the incident phase pointers of appropriate half edge corresponding to E1 and E2. So this is the end of this part. In the next video we will see the final algorithm, the global algorithm that is used, that can be understood if you have watched this video and the previous video. And thank you if you find my videos and my content informative and really helpful. Please like, share and subscribe to my channel.